Hey guys, welcome back to Science. We are continuing our investigation into why some sounds are different than others by looking at pitch, volume, amplitude, waveform, and wavelength. So if a dolphin whistle is really high-pitched, what would that tell you about the wavelength of the sound wave? Well, I remember that wavelength is how far apart the waves are from each other, and that if they're high-pitched, they're actually really close together. So that sound wave could look something like this if it's high-pitched. If a whistle is low-pitched, that would tell me that they're very far apart or that they have a very large wavelength. All right. Now we're going to look at 3 dolphin calls. 1, 2, 3. And we're going to label the amplitude and the wavelength. I remember that the amplitude controls the volume, and the amplitude is how high the wave is. So from the very middle to the top, that is amplitude. And I know that wavelength is the distance from one peak to the next, and that controls the pitch. So this is the wavelength. Something I'm noticing here is that they're all the same height in numbers 1, 2, and 3. So that means they're all the same volume. What's different though is the wavelengths. So that means the pitches are different. So what do you think each whistle sounds like? Well, I think it's this one. For number 1, it starts out low pitched, then it goes really high pitched, and then back to low pitched. In the second one, it seems like it starts out high pitched, then goes down a little bit, and then goes right back up. In the third one, it starts out high pitched, and then it goes really low pitched. We're going to try a fun challenge. We're going to try to go to our sound waves sim, and we're going to try to make one of these sounds, and we're going to try to match the wave printout here to one of these. Now I'm just going to do number 1, so if you guys would like to try this at home, you have all the login information. You can try it with number 2 and number 3. So I'm going to pick the first signature whistle. A couple things I need to remember is that I don't need to change the amplitude because it's the same volume all the way throughout. I'm only going to be changing the wavelength. So our options are short, medium, or long. So this starts with a long wavelength, then we go to short, and then back to long. Let's see if we can figure that out. So starting with long, let's click play. Then we'll go to short. And then you see they're really close together. And back to long quick. Okay, let's see if we did it. So long, short, long. How did we do? Okay, pretty good. I think I need to switch to the short wavelength a little bit quicker. Let me try one more time. See if we can get a better version. So we'll start with long. Short, and back to long. Okay, I think this one looks much better. So we have long, short, long, and that looks about the same as number 1. Nice. Okay, now again, if you guys want to try this at home, try with numbers 2 and number 3. It's kind of fun. Now we have another email here from Maya Martinez, the park superintendent. She's collected some extra data that might be helpful to us. They have 3 waveforms for dolphin calls, from a mother dolphin and from another dolphin. Now they saw that the dolphin calf only responded to one of those calls, and they're wondering why it only responded to one. So we're going to write a scientific explanation to help her. And we're going to answer these 2 questions. How was the dolphin calf able to hear his mother even though he was really far away? And how did the dolphin calf know that that call was from his mother? So here are the 3 calls. 1, 2, 3. The calf, the baby dolphin, only responded to this one. I wonder why the calf didn't respond to this one or this one. And we also need to figure out how he was able to hear his mother even though she was really far away. So there are some clues in the amplitude and in the wavelengths of these 3 waves that will help you figure out the answers to those questions. A quick review before I send you off. Remember that volume could be loud or quiet. volume relates to amplitude, which is the height of the wave. So if you see a really tall wave or large amplitude, that means it's really loud. If the wave is really short or small, that means it's quiet. And then we have pitch. Something can be high-pitched or low-pitched, and that relates to the wavelength. That's the distance between the peaks. So it could be long, and that means it's really low-pitched, or it could be short, really close together, and that means that it's high-pitched. So your job today is to look at the waveforms that I just showed you right here, 1, 2, 3, and then you're going to write your scientific explanation in the Google Doc. Answer these 2 questions. How was the dolphin calf able to hear his mother even though he was really far away? And how did the dolphin calf know that call was from his mother? Good luck and happy working. I'll see you guys next time.